Hello and welcome back. We are now into Module 2. So we're going to look at setting up an FEA simulation on Fusion. In this video, we are going to look at how to actually design for FEA. We are going to have a look at the user interface for the simulation environment. Going to dive into some of the key features of it, like constraints, loads, materials, and then obviously as we move through, eventually get it ready so that we can solve that study. So let's jump into Fusion and see how it looks. When running an FEA study on Fusion, you could do it just by opening up an existing model from your data panel. For the purpose of this video though, I'm going to show you quickly how to design a model that we're then going to create an FEA for. So what we're going to be creating is a really good civil engineering example, and that is going to be creating a simple I-beam to then do some testing on. So to start off, we're going to try and follow the left to right along the top. So we're going to create a sketch just to start our design off. We're just going to pick either of these two, and we're just going to select a 2-point rectangle from the top. Going to place the first corner in the origin, and just drag it off so I can start to select my dimensions. So I'm going to make the vertical height of this 50, and then just press tab just to change over to the other side, which we are going to make 500. Press enter once you're done. And then what I like to do, just because this is quite a big sketch, just click the home button, and then just click on front again, just to get it at a sensible size and shape for us to carry on working. So that is now the bottom section done of the I-beam. So what we're going to do now is the vertical column that just joins to the next horizontal rectangle at the top. So to do this, we actually need to create a reference point to start the center of our next rectangle. To do this, I'm going to go to the line tool. This time, I'm just going to click on construction because this isn't actually part of our design. We're just using it as a reference. Once you hover over this line, eventually you should be able to find the midpoint, which is shown by this triangle on the cursor. Simply click on that, and we're going to make this 150. Click the tick. And then what's really important is once you've gone off the line tool, just untick construction, just so the next lines that we add, it knows that they are actually part of our design. Our next shape that we're going to add is another rectangle, but this time we are going to go to create, and we're going to select a center rectangle this time instead. We're going to select the end of that reference line just as our center point. Again, the cursor should change when I've locked into this section, and it should be set at 300. Then we can simply press tab on the keyboard and just change over to this side. I'm going to set that at about 200. And then again, I just need to repeat what I did before. So I'm going to select 2-point rectangle again. And I should be able to place it level with this point and also on that axis just there. Should be 50 by 500, just so it matches that section down at the bottom as well. Once we've done this, we can click on Finish Sketch. And then to make this 3D, we're just going to use the Extrude tool. Select all three of those profiles. And we're going to extrude this out by 5 meters. Now, you can either be efficient rather than lazy like me and just do 5M. It's automatically going to know that we need that measurement in meters. Or if you'd like your students to do a bit of maths, you can get them to do the conversion from millimeters, which is going to be 5,000 millimeters. Click OK once you've set that size. And that's all we need to do as far as the design is concerned. Now that we've got our model done, we can change over from the design workspace and over into the simulation workspace. Click on design and switch over to simulation. Now, there's plenty of different simulation types we can run on Fusion, but for the purpose of this video, we are going to stick with a static stress. Click on study. With the simulation workspace, the user interface isn't too different to what we'd expect on design. We've still got a browser over to the left, even if some of those options and menus are slightly different. And we've still got our tools and our setup options along the top. Again, with this, we're going to stick with that same workflow and try and work from left to right along the top to try and complete our study. So first one is study, which is just for creating new studies. Simplify, which can be a good tool for simplifying a complex shape just to sort of get an estimate of what it might be like. But what we're going to start with today is in the materials section. And the one we're going to select is study materials. So this is what's included within our study. In this dialog box, what we can do is we can simulate with the same as the model. So whatever we've made in the design workspace, it'll just keep that same physical properties in this one. On Fusion, the default material is steel. What I'm going to do is I'm just going to show you the wide array of different materials we can choose. Some of these materials, however, will have this warning symbol next to them because something like air isn't exactly going to be the best material for running a static stress. Because this is such an extensive range of materials, if you want and you have an idea of what you're going to use, you can just press the letter on your keyboard and it will jump to that one. So for this, I'm going to go with stainless steel 17.4. And I'm simply going to click on OK just to set that as my material. Next on our workflow is to set some structural constraints. So what this means is we have to lock somewhere on our part in place because a clever guy named Isaac many years ago predicted that if we were to apply a force to an object that's not fixed down or there's no opposing forces, it's going to continue to accelerate forever and ever, and that's obviously something we don't want. So we're going to select structural constraints for our one. We're going to leave it as fixed. We're going to lock it into all three axes. We're simply just going to click on this end face. Click on OK. And moving along this left to right, we're going to start setting out some of the forces which are known as loads that are being applied to this. You can, if you really want, if you're working on a part that could be in outer space or another planet, you could actually turn the gravity on and off. You could even edit the amount of gravity and also the direction, just in case for whatever reason your model is orientated slightly differently. What we're going to stick with though is structural loads. So this is just us, as it says in the box, applying some sort of force to our part. We're going to leave it as a simple force for now, and you can apply this to edges or to faces. And because force is a vector, we need to add both a magnitude as well as a direction. So because this is being done just as an example, what I'm going to do is I am going to apply a really large force to this just to give us a wider set of results. So I have set this to 50 million newtons, which does seem quite ridiculous, but it's just to give us more results to explain later on in the videos. Click on OK. And we're also going to set another structural load onto this opposite face from our constraint as well. This time it's going to be slightly less. We're just going to apply a magnitude of 50,000. And again, click OK once we've set that. Next, we're going to skip a few of these and we're just going to go straight over to the solve section. So One of the first ones that's really good for getting used to and practicing FEA studies is this pre-check. Now, what this is going to do, it's going to run a quick check on the parameters that you've put in and almost like a checklist of what you've actually set up. If it comes up as yellow, it's a warning, and it might be that something is not quite right, but it could still work anyway. If it's red, for whatever reason, it's unable to solve the study, but it will give you suggestions and reasons for this. If it's green, like what we've got here, what you've got to remember is Fusion isn't going to be perfect, but what it's doing is it's assuming, based on what you've got, that we are going to be able to run that study. So our next option is just to go to Solve and actually select the Solve button. Just to give you a bit of an idea of this cloud credits, they are a in-app purchase on Fusion. But if you are running this on an education account, you will get unlimited credits for free, just as it says there. One of the issues that I've seen now quite often with teaching students is that sometimes it will be telling them that they've got no credits available. If you simply click on account, it will allow you to ensure that you are using the credits and tokens in your education account rather than the other account that may exist. Once you're happy with how your study is set up, simply click Solve Study and wait for the magic to happen. Whilst you wait for that to load, you can go make yourself a cup of tea or a coffee, whatever it is that you prefer, and join us for Module 3, where we will look at how to actually analyze these results once they are complete.